Welcome back to Precalculus 1. So we're going to talk about inverse functions, one of the very important, very useful things, concepts in mathematics. We start with the notion of, in certain cases in life, you are able to undo things you do. For instance, can press on the switch and turn on more light. The other one. Yeah. And the other one. There we go. So we said that the brightness over here depends on how many lights are on. So we also said that the switch over there on the wall has a particular function to it, and that function is to control these particular lights in the classroom. So now, by toggling the switch on and off, you apply the function, you undo. Apply, you undo. Apply, undo. So, what we are going to do now is we are going to see what mathematical functions will have a way to be undone and what could not be. We're going to see that every single function in the galaxy has an inverse, but not every inverse is a function. And this is where it gets a little bit tricky with terminology. You really have to pay attention. The word inverse and inverse function are not the same thing. They both get to undo. Now, we said that we are mainly interested in functions in this course because this is the pre-calculus course, and calculus mainly deals with functions. So we want to see how to differentiate between all of the functions whose inverse is not a function and the other functions whose inverse is a function. And also how to find that inverse, and also how to check the validity of that inverse. So all of those concepts are in this section 1.8. Now this stays with you for the rest of your math education because guess what? PreCalc 2, trigonometry, you will have 6 inverse trigonometric functions. Inverse sine, inverse cosine, all of them. Inverse hyperbolic functions in calculus, and so on. So you are going to have this inverse. And the concept of the inverse is extremely important. It's all over the place. So let's see what it's all about. I will start with a simple notion of f of x is equal to x plus 3 and g of x is equal to x minus 3. So I'm just going to start here. I'm giving you two functions, and I will ask you how much is f of 8? How much is f of 8? 11, because 8 plus 3 is 11. But I'm just going to ask, how much is g of 11? 8, right? So you have 11 minus 3 equals to 8. So we're back where we started. I can draw that on the diagram like this. Pick value 8 over here, pick value 11 over here, and say, if I apply function f on 8, I will get 11. But then if I apply function g on 11, I will get 8 back. So this type of a property, where you have this kind of correspondence between the pairs, is called the inverse function. Which, I mean, g is the inverse function of f, and we denote that with this little negative 1 on top. So we have inverse function f to the minus 1 of x. And technically, what is its job? Its job is to undo every calculation that f does. So you know that you can plug in, because domain of the linear line is all real numbers, you can plug in all infinity of numbers one by one, compute the y values, and the inverse function f will be returning the original values you plugged in the first place.
Every single time.
Every single time, no exceptions. It's math. Let's take a look at. So again, we're going to use this in chapter 3 again in this course. Let's take a look at another function. So let's say f of x is equal to x cubed. So how much is, let's say, f of 1? How much is f of 2? Okay. And how much is f of 3? 27. We can go on forever, right? You can pick numbers in between if you like pain. Now, what would be the function that would undo this? So I got 3 answers. They were all different at the same time. So let's go one by one. I'll list them all. I'm sorry? Oh, so you're saying cube root of x like this? Anything else? 1 over x cubed. Anything else? Ran out of ideas? Negative x cubed. Anything else? Yes? X to the power of 1 over 3. Is that what you said? Aha. You want the 1 over 3 over here. Like this? Okay. Anything else? So these are all possible answers. Now one of these is correct. The other ones, nope. Which one? First one? Now try it. Now you have numbers over there. Start plugging in numbers on the right. See if you get numbers on the left. Oh, it's the first one, huh? Yeah, it's the first one. Good. So, the first one is the inverse. We gotta get rid of the rest. So now you have the inverse function computed at 1 is 1. Inverse function computed at 8 is 2. And the inverse function computed at 27 is 3. Cool? It's extremely cool. Next one. F of x equals x squared. F of 1 is 1. F of 2 is 4. F of 3 is 9. Do we have inverse function for this one? Square root of x? Yeah, this is actually a little bit cheap on my part to ask a question this way to just get you to make a mistake. But let's test this. Let's test this, guys. So what's the inverse of 1? Square root of 1 is 1. Awesome. And what's the inverse at 4? 2. And what's the inverse at 9? It kind of looks good, right? Until we run into a problem that over here f of negative 1 is also 1, f of negative 2 is also 4, and f of negative 3 is also 9.
So could you do the absolute?
It's not the absolute, it's that every single answer that you get here is positive negative 1, positive negative 2, positive negative 3. Now, do you actually have a function if you have two y values for the single input? No. So there is something wrong with x squared, right? So now let's just step back for a second. Go back to this example here. I want to draw a graph for this, even though we're not, graph literate yet, I would say, because that's chapter 2 for polynomials. But look what's happening here. If I pick this value, we bounce off of the graph and we get that value. So the value a will produce, let's say, b, and the inverse function will take b and give back a. Do we all see that? Yeah. So you can pick 2a. Let's say this is 2. So when you plug 2 into the function, it will give you 8 back. This is 0.2, 8. And then if you pick 8 here, the inverse will give you back 2. Because it's the only relationship between these two numbers. Because you have to go perpendicular, 90 degrees, and you have to hit the function. So there's no other way to get this in any way other than this. So A is going to map into B, and then B is going to map back into A. Now if I draw, and then anything that you pick on the inverse, no matter where you pick, as you can see, it's always a one-to-one correspondence. But now if I draw the picture, the graph, for x squared, do you see if I pick this value here for the inverse, it spits out this value and this value. Do we all see that? So for inverse function, the input is the y-axis. So now this input will produce two answers. And what do we know about that situation? Not a function, right? So we have to be careful about that.
So do we just write no inverse?
Aha! This is where we start now talking about the words that we have to be careful about.
No inverse function.
That's the one. No inverse function. Is there an inverse? Hell yeah, there's an inverse, but it's not a function. Every single equation will have an inverse. Every single one of them. But many of those are not functions. And you just saw one, which is x squared. So x squared is going to have an inverse, and that's going to be plus minus square root. But that's not a function. Because when you draw plus for the square root, and then you draw the minus for the square root, so this is your plus square root x, and this is your minus square root x, you see that it fails vertical line test, which means it's not a function. But its inverse, it exists, it's right there. And I can use it to get those values that we talked about up there. But then there are some other things that we can do with it. So now, talking about inverses, number one is, you must know that function changes x values input into y values, which is output. So just like this, f of 3 is 9, right? So that's the first concept from the first class. The function is going to change input values into output values. The inverse function is supposed to bring them back. So the inverse function is supposed to take the 9 and give you back 3. Now, inverse and inverse functions both do that. However, the inverses that are not functions will be like this, failing the vertical line test. They can fail it infinitely many times. You will see when you start taking the Precalculus 2 for trigonometry, you see an inverse sign. Inverse sign is going to be a wave that goes downwards like this, and you cut it with the vertical line test, it fails infinitely many times, which is very interesting. So now the question is, how do we find an inverse? Or should I say the inverse? Now observe that I'm not using word function. I just want to find the inverse, and then from the inverse I will recognize whether it's a function or not, which is, we have the vertical line test, we have those is there a y squared clues and so on. So what we are doing is we are simply learning the procedure to find any inverse, and as I said, every function has it, but then we are going to take a look at the inverse and say this inverse is or is not a function. So the simplest procedure, the number one step, is to swap x and y. So swap all of those, 2, solve for y, and then 3, replace y with f negative 1 like this as the inverse. So let's talk about this. So these are your, if you want to think of this as steps, right? So what do I have? Say that f of x is equal to 3x plus 5. That's it. So you are going to rewrite this as y equals 3x plus 5. So that's the first step. Oh no, so first step is now coming. So first step says swap x's and y, so x equals 3y plus 5. So this is like a rule 1. Now, step 2, solve for y. So that's going to be x minus 5 is 3y. And then finally, y is equal to x minus 5 over 3. In the last step, replace the y notation with f minus 1 so that you can pair it with its function. Don't get married to this idea that it's always f minus 1, g minus 1, h to minus 1. Any of the letters that could be plugged in for a function, right, instead of f of x, will have the inverse with that negative 1. Now, why is this third step so important? If I know this is already inverse, isn't that good enough for us? The answer is yes, it's good enough for us, right? But this notation here clarifies that this is a function inverse. Function, right? Function. Because you will see when you get this step done, for those that this is not a function, you will not be able to isolate y, in some sense. Now, I would like to test this. So, give me a value for x. 3. And if this is 3, what is the value here? Very good. Now, what is the f inverse of 14? See? Exactly where we started. 3. The inverse function is supposed to take the output from the function, grind through, and give you back the original value you started from. If you want another one of those graphs with sets, you have number 3 sitting here, number 14 sitting here. F is going to take it this way. F inverse is going to bring it back. Now, I don't think it takes too much effort to understand and see that the inverse of the inverse is the original thing. As I'm trying to scout for additional piece of clothing that is not used at the time, I don't see any time. Think of it. You invert the sweater, right? Invert the sweater. You invert the sweater, and when it's wrong side out, you invert it again, and it's right side up, right? So, inverse of an inverse is the original thing. If I am to swap this y and this x here, because this is an inverse, if I am to swap them and solve, I will get this back. So, it's an infinite loop there. So, you only need to do this once. There's no need to keep doing inverse, 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 inverse. So you have original function, and if you need the inverse, you just do procedure once, and you will get the inverse. If you are to invert the inverse, you will go back to original state. Yeah.
So, like with the exception of the square root, like how?
It's not exception. No exceptions in mathematics.
Okay. Okay.
No exceptions. Square root, x squared does not have inverse function. We're getting there. We're getting there. So what you saw over here is the situation where you start with the function, you do the inverse, you end up with the inverse which is a function. So the world is beautiful. Now we're going to jump into x squared situation and say if f of x was given as x squared, we can write it as y equals x squared, then swap x and y, and then when you want to solve for y, what happens? You have to square root both sides. As soon as you square root, you put plus and minus. And then there's your y equals plus minus square root of x. Now, just because there is a plus and minus there, we know that this thing is not a function immediately, if you get that plus minus. So now, if I'm going to graph this again, so if I graph the original function, it's going to look like this. And then if I graph the inverse, it's going to look like this. So now, this branch here is positive root x, and the branch on the bottom is the negative root x. Observe that it fails vertical line test. Which implies not a function. I have to remember that test, guys. It's a very important test. So it failed. We started with a function. We all know x squared is a function. We can compute any value in it. Give me positive number, negative number, whatever. But then, when we find the inverse, we find that the inverse is not a function because it fails the vertical line test anywhere other than 0. Some mathematics can be done with this in calculus. We'll see, plus differentiation and stuff. But now we don't have to worry about it. We're going to worry about how to test if two functions are inverses of each other. So the way to test if two given functions are inverses of each other, we use function composition. And we use it in this way. If you compose f with the inverse, you will get the same as if you composed inverse with f. So yeah, it's commutative. And the answer at the end was just going to be x. So if these conditions hold, that means that the two functions that are given to you are inverses of each other. If you get anything else about x, that means that something is wrong. They are not inverses of each other, and then you have to go and figure out what went wrong in calculations, or maybe they are not, right? Fair. Bueno? So let's take our previous example was 3x plus 5. So f of x was 3x plus 5, and the inverse for this was x minus 5 over 3. Is that true? Yeah. So now I know they are inverses of each other. I already know that because I just did the problem earlier. And we are technically verifying our formula here. So I'm going to say the function composition between the original function and its inverse has to work out to be x at the end. So I have 3 times the inverse function, which is x minus 5 over 3, and then we have plus 5. So guys, this thing over here plays the role of x in the original equation, but now since we are plugging in inverse in there, that x gets replaced with what the inverse is. 3's die off, x minus 5 plus 5, 5's die off, and you just have x. So this is definitely good. This is definitely function inverse pair. They're definitely paired together, they're function inverses. Now you can also check, and I will let you do this for about 17 seconds, figure out the function composition the other way. It also has to give you x.
I know, I think just moving, walking straight.
Thank you.
You want to put the problem on the board?
No.
All right, so let's take a look at this. We start with the inverse, which means that the function will be plugged in here and then minus 5 over 3. The function is 3x plus 5, and then we have minus 5 over 3. These guys cancel, and then 3's will cancel, so it's x. Awesome. Now let's see what's happening with x squared situation. I run out of ink. So I have x, so function f of x is going to be x squared. We write y equal x squared, x equals y squared, y equals plus minus square root of x. We did all of this stuff, and then we can't write this inverse function because it's not a function. So we don't get to do composition. Right? We don't get to do the composition. However, I'm going to introduce now a concept. This is very important, guys. It's going to be used in Precalculus 2 a lot as well. I'm going to introduce a concept of a restricted domain. Restricted domain is going to fix this issue. So now, what I'm going to do is I'm going to say that my f of x equals x squared, but it's on the domain 0 to infinity. So technically, the new creature that I'm looking at looks like this. That's it. It's just half of the graph. Now, what is that going to do? Calculation remains the same, but now you're going to end up with f of x equals only the positive branch root x, which means that now we have the inverse and it's just root x. So this is extremely important because it will be repeated again in Precalculus to find the inverse functions for all of the trig. All the 6 trig functions. So we already see on the left in black that we don't have inverse function at the end. But if we introduce the restricted domain and we restrict it clever way so that we eliminate the part of the graph which kind of doubles up situation here, then we go through this procedure and we don't get a negative branch on x. So it just becomes positive root x, only one of those. And now that is a function. So I'm going to label this one. This is your f of x. And now in blue, I'm going to draw a square root of x, which is the inverse. So now here they are, both function and its inverse, on the same graph paper. And now, this is something that it's always there on exams and final exams and so on. And for whatever reason, you are not processing it well. So pay attention. This is literally talk for the grade now. Your functions that you get, f of x, you can graph those. Since it's given as a function, you know that it already passed the vertical line test because it is a function already. We are going to introduce horizontal line test. In order for a function to have an inverse function, function has to pass horizontal line test. So you can graph it and then you look at it. So now I'm introducing the horizontal line test idea. And horizontal line test says if f of x passes horizontal line test, then f of x has inverse function. And I'm going to box that statement. Because, guys, why go through all of these calculations, even for x squared, which is the cheapest one of all, if you can just say, okay, f of x is given as x squared, its graph looks like this. If I draw a horizontal line test, it fails, which means no inverse function. It has an inverse. We know that it has an inverse. Inverse was plus minus square root of x. Now observe what restricted domain did. For the restricted domain, we said use only 0 to infinity, which graphs this way, and look at that. Pass horizontal line test. And because it passed horizontal line test, we know that its inverse of x squared on the restricted domain is inverse its function. I don't know if this sounds too picky to you, but guys, this is the bare minimum of what you absolutely have to know in order to continue down the line with math. So to recap, you start with the function. You can graph that function immediately. If it passes horizontal line test, that function will have inverse function. To find inverse function, you swap x and y. You go through algebra to isolate y. And since it passed horizontal line test, you will have it as a function. If it didn't pass the horizontal line test, the inverse still exists, but the inverse would not be a function, because if you draw the inverse, if you graph the inverse, you will fail the vertical line test. So now you have these two line tests, and both of them are applied on the original function. So both of them are applied to a function that is given to you in a problem. You apply vertical line test to check if the function is actually a function, and then you immediately apply horizontal line test on the same function to check whether it has inverse function. If both pass, you have everything. If both fail, you have nothing. But then you can pass on the vertical and fail on horizontal. And then you still have inverse, but it's not a function. The last thing that I want to talk about here is the concept of symmetry. You could see it a little bit over here on the sloppy graph that I provided. The original function and the inverse function are always symmetric on the line y equals x. And that should be common sense, because I told you that you find an inverse when you swap x and y. So they have to be symmetric on the y equals x line. So y equals x line over here, I'm going to draw and then erase. It's like this, and you can see that it's symmetric looking at that line. So now I will go and say y equals x cubed. We draw the graph for x cubed, and immediately from this graph, what do you know?
But it is a function and then it does have roots.
Yes. So as soon as you draw this y equals x cubed, you see that it passes vertical line test, which means that x cubed is a function. So it passed the vertical line test. Awesome. And it also passes horizontal line test, as you can see, which means that it has inverse function. Not just an inverse function. If it has an inverse function, that means that we can draw a 45-degree line through the origin, and the graph for the inverse must be reflected on it. I don't even need to know what the equation is. This is x cubed, and the red was, let me just go with f of x, and this one is inverse. Now I know that the inverse for this is cube root of x. We had the example earlier in a lecture, but now I'm just showing you that I don't need to know what is the function that I need to draw for inverse. As long as I have a drawing, as I have a graph for the original function, I am immediately able to draw the graph, right, the other one, because it just has to be symmetric. So draw the inverse for absolute x. Let's go absolute x minus 3. So draw the inverse for absolute x minus 3. That means you first have to graph absolute x minus 3, and then observe the y equals x line and draw the inverse. Yes. You always have an inverse.
An inverse function.
That's true.
I'm correct.
That's true. Bye.
I did.
Okay, would anyone like to take the spotlight and do this as a lecture for everyone? Use words, explain everything.
Alright. So usually it's the x, absolute value of x, but it's shifted to the left.
Right.
Right? To the right. And then it's just kind of like that. And so if you do this, the vertical line test, it passes, which makes it a function, but then when you do the horizontal line test, it fails. So it makes it not have an inverse function.
That's good.
Unless.
Now, can we draw? Can we still draw the inverse? Because it does have an inverse. It has.
If there's a restricted thing.
No, we don't have to restrict domain. Can we draw it as is?
Oh, yeah.
Does anyone want to draw that one? Anyone wants to draw the inverse? Come on.
It would be the other side.
Nope. You want to draw?
Oh, yeah.
What is the first thing we have to draw? A line of symmetry, thank you. So we draw a line of symmetry, and then off of that line of symmetry, we draw everything else. Line y equals x. You're backing up now? All right, let's see. Line of symmetry, guys. Yeah. Oh, I know. I can't. What do you mean you alone? So there you go. You will never know.
Wait,
Look at that hunger for math. I simply have to do it now.
would it be?
I just sat down.
Okay.
All right, let's take a look. So this is the f of x, and we call it f of x because it is the, we know it's a function, right? As you said, it passes through the vertical line test. Now, for inverse, I'm going to draw the symmetry line, which is this line here. And I am simply going to reflect every point of our graph through that line. So, let's think about this. This point here has the coordinates 3, 0. When you swap x and y, it becomes 0, 3, so moves over here. Pick this point here. This point here has the coordinates 4, 1. When you swap, it gets 1, 4. 1, 4 is here. This point over here has the coordinates 5, 2. When you swap x and y, you get 2, 5. It becomes this one here. And one more. You take this point here, which is 6, 3. When you swap it over, it becomes 3, 6. And that's one right there. Now we go on the other branch. This point here has the coordinates 2, 1. And when you swap the coordinates on that one, they become 1, 2. 1, 2. Right here. So the inverse is going to look like this. I know, too many lines, but I'll draw it again over here. That's how inverse looks like. Clearly not a function. Clearly not a function. It fails the vertical line test. But we knew that because the original function f of x failed the horizontal line test. So, yeah. Awesome, right?
Yeah.
Yeah. We're going to do 5,000 of these on a test.
Wait, and would the inverse function be x plus 3 absolute value equals f?
There is no inverse function here.
Oh, so you just don't have a function.
We have
You
inverse.
can draw it, but you can't write the function. Right?
Yeah. So, okay, since there is a question, guys, let's look at that one. So, can I mathematically flip this around? And the answer is yes, I can, right? I swap x and y. And there you go. That's what it is. Yeah, you can't do anything, can't simplify, can't move the absolute values, anything like that, so you're stuck there. But you can see that y, right, you can see that. Yes, that's we're done with this, so I'm going to just. All right. That's it. So let me stop the stream.